Okay, this starts off Unit 6. This is transformations, similarity, and congruence. And in this lesson, we're going to be talking about transformations and verify experimentally the properties of rotations, reflections, and translations, which we'll get into in just a minute. But basically, we're going to talk about lines being taken to lines, line segments to line segments of the same length, angles taken to angles of the same measure, and parallel lines are taken to parallel lines. I know that kind of sounds confusing, so we're just going to kind of run through it. So the first thing you need to know is there are 4 types of transformations. And the 3 that we're going to be talking about today are translations, which this is an example of a translation, which is a slide. And then we have a rotation, which you probably guessed is when a figure rotates about a point. And then there's the reflection, just like selfie, which is that mirror image. And then this one we're not going to mention in this lesson, but the 4th type is called a dilation. These are kind of fun. Okay, so we're talking about this line segment AB. Okay, suppose AB is translated in some way. So the translation was the monkey from the page before, and it's a slide. So it's asking, well, the image of AB, the image is after you translate it. Will it also be a segment? Is it possible to translate it in a way that results in a figure that is not a line segment? So a translation is a slide. So we're going to take this line segment and slide it. There's a translation. There's another translation. There's another. So what we're trying to see is if we move this in a certain way, is it never a line segment? Or does it remain a line segment no matter what we do to it? And then how do the lengths of AB and its image compare? So if you go back to the original and you look at the length of AB, after we translate it, did it change at all? And it's pretty simple to see that no, it doesn't. A translation does not change. It will remain congruent because it's just taking that image and sliding it around. Okay, the next one, we are going to be talking about that line segment again, but now rotation. So if we take this line segment and we rotate it, is it possible to rotate this in a certain way that will result in a figure that is not a line segment? And as you can see, the answer again is no. A rotation changes its location, but it doesn't change the actual line. And how will the lengths of AB and its image compare? Well, did it change the length? Nope. So no matter what we do to this, if we rotate it, it's going to continue to keep that shape. And lastly, we have reflection. So suppose AB is reflected. Now this one's going to take me just a second longer to talk about because I got to do something fancy with it. So a reflection is a flip. If we flip this guy, this is a flip. Okay, this has been reflected either that way or that way. Has it changed its shape? No, it's just backwards now. Now we're going to take it again and we're going to flip it upside down. So it's now been reflected this way or this way. But as you can see, the shape did not change. It's still a segment, and the length also did not change. So with line segments, no matter what we do to it, reflection, rotation, or translation, that line segment is going to stay a line segment. All right, now we're going to use the same idea. We're going to talk about this angle A. So if we translate this angle, does it change? Does the angle itself change? If we slide it up, we slide it down, we slide to the left, slide to the right. One hop this time. Just kidding. Okay, so translation of a line or of an angle does not change the angle. Okay, now we're going to keep that angle and talk about rotation. So if we take our angle and we rotate it, does that angle itself change? It might look different, but if you look at the measure of that angle, it looks like it's less than 90 degrees. Maybe it's about 60 degrees. It's keeping that angle the whole time, no matter what. And the size of the angle is not changing. And then last but not least, we have the reflection. So if we take this and we flip it, so it's been reflected either this way or this way. Has it changed? Nope. And then if we take it and we reflect it again, now it's been reflected this way or this way. Has it changed? There's no way that you can reflect this guy that will result in a figure that is not an angle and not the exact angle to be exact. And last but not least, we have parallel lines. So if we take these parallel lines and translate them, they go to the side, they go down, they go up, you're going to maintain that congruence. It's not going to change the distance apart of the lines or the length of the line. So there's no way that you can translate this image without maintaining the congruence. We're going to do the same thing with rotation. So we take our parallel lines and we rotate them around. Woo! As you can see, the slope might look like it changes, but the relationship between A and B stays exactly the same, even if it's spinning around. And last but certainly not least, we're going to take this and we're going to reflect it. So if we reflect to the left, or if you flipped it over here to the right, whoops, either way, it's not changing that shape. And then if we do it again and we reflect it up and down, there's no way we can reflect this that we're going to get something other than parallel lines. Okay, so using a rotation, reflection, and a translation, back to these guys. Whoa, 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 whoa. Transformers. No matter what we do to these shapes, the translation, the rotation, and the reflection, it is not going to change the shape from the original.